This is a night notes lesson for 2 investigations, so we'll knock out 2 in this video. So it's 2.1 and 2.2, which we'll refer to in class. So what are we going to be learning about? Here is a short preview of the problem for 2.1. Let's play this, if I can get it rolling here.
This Ferris wheel. I'm gonna try this one. I've gone all the way around. Wait, I haven't. Now I've made it back to the start. Already back at the top. When will we both be at the bottom at the same time?
So that's a video. So in that short video, there's a focus question. It's when should we know if we should use a common multiple, or a least common multiple, or a common factor, or a greatest common factor to help us solve a problem. So I want you to pause the video now and write down the terms that I have from your notes packet, these 4 terms from your notes packet, and you can pause the video now. All right, in your notes packet there was a small little typo, so I kind of made an overlay, and let's just define these. I'm going to use a lightsaber because I want to. So a common multiple is a multiple common to 2 or more factors. So let's do an example of what a common multiple would be. If we have 3 and 4, let's just write the multiples of 3. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, 3 times 7 is 21, 3 times 8 is 24, 9 times 3 is 27. So those are all multiples, and I call that skip counting. So you just skip count, that's all that is. And let's do the 4. So we say 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6, 4 times 7, 4 times 8, and 4 times 9. Sorry about the small print. So what do we have now? If we want to find a common multiple, it's just any multiple that's common to those two numbers. So what are they? Let's see if we can find some matches here. 3, 6, 9. Okay, I see one. I'm going to highlight it. Let's highlight it in red. So 12 and 12, those are common multiples. See if there's anything else. 24 and 24. And we could go on to infinity and find lots of common multiples, but that's an example of a common multiple. So then that leads you to the next question is, what's the least common multiple? The least common multiple is a multiple of the least multiple that 2 or more numbers share. So if we have the multiples of 3 and 4, just as we did up here, what's the smallest multiple that they share? In this case, is 12. So the least common multiple, the LCM, is 12. Common factor, a factor that 2 or more numbers share. So if we write the factors of 15, 1, 3, 5, and 15, and we could pick any number. That mostly we'll always use a composite for examples, but here's 24, 1, 2, 3, 4, 6, 8, 12, and 24, and we could obviously make pairs, factor pairs out of those. But we want to know what's a common factor they share. Well, they share a common factor of 3. So we have common multiples and then common factors. So the greatest common factor, what's the greatest common factor that they both share? Well, it's the factor that's the largest that they both have in common. In this case, it's 3. Okay, so those are the terms, and we'll go over these a lot. So I do go pretty fast in these videos, so you don't have to spend too much time. So once again, is the y is we're continually building our foundation. And here's another reason why you might be given another problem, as you will in class. So the first problem we'll do is the problem that deals with the Ferris wheel. Somebody gets on the large one, someone gets on the small one. When will they meet at the bottom? This is another problem that deals with cicadas, and I hear a lot of those chirping in Iowa. So let's play this and listen. The focus question here is, how can you find the least common multiple of 2 or more numbers? How can you find the least common multiple of 2 or more numbers?
A cicada is a large insect with long, transparent wings. During mating, the male cicada makes a loud, shrill droning noise after dark by vibrating 2 membranes on its abdomen. There are many broods or groups of cicada in the United States, and they hatch at different times every 13 years or every 17 years. When the female is ready to lay her eggs, she cuts slits into tree bark and deposits them inside the slits. After 6 to 10 weeks, the ant-like nymphs hatch, fall to the ground, and burrow several feet into the ground. Depending on the group, the nymphs spend the next 13 or 17 years underground, feeding on the sap from the tree's roots, waiting to emerge and start the cycle again. Sometimes, though, the hatch cycle of the broods overlaps, as it did in Missouri in 1998. When will the 17-year and 13-year cicadas next appear together?
All right, so that's a good math problem. When will the 17 and 13-year cicadas appear together? So that's another reason why we're learning. We're going to learn how to use numbers to answer real-life questions and problems. All right, so how are we going to do this math? Well, to learn about common multiples and common factors, we're going to use these problems. And the first problem that we'll use deals with the Ferris wheel problem, and that's problem 2.1. So we're going to introduce this here. Part A says the large Ferris wheel makes 1 revolution in 60 seconds. So that means it goes around, if it's a large wheel, it goes around once every 60 seconds. Okay? The small Ferris wheel goes around once every 20 seconds. Okay, so they'll go up and around, up and around. B, the large Ferris wheel makes 1 revolution. Let me get my clicker here. 1 revolution in 50 seconds. The small Ferris wheel makes 1 revolution in 30 seconds. C, the large Ferris wheel makes 1 revolution in 20 seconds, and the small one makes another one in 11 seconds. So the question they're wanting you to answer for each of these, A, B, and C, is for questions A through C, find the number of times each Ferris wheel goes around before Jeremy and his sister are both at the bottom again. And my hint for you on this question is draw pictures just as I did here. Draw pictures. So this would be the first Ferris wheel, 60 seconds, 20 seconds. The second letter, B, this one will be 50 seconds, this one will be 30 seconds, and the third will be 20 seconds and 11 seconds. So we're trying to find out when Jeremy and his sister will both be at the bottom again. All right, so that's problem 2.1. And problem 2.2, it's kind of a problem that you can hear outside. 2.2 says, Stefan's grandfather told him about how cicadas sometimes damaged his orchard. One year there were so many cicadas they wrecked the buds on all of his young trees. Both the 13-year and the 17-year cicadas came up that year. So the questions are this. A, suppose 13-year and 17 cicadas both appear this year. So this year, both the 13 and the 17-year appear this year. Okay? When will both of them appear together again? Interesting problem. Factors, multiples, common factors? I'm not sure. B, suppose there are 12, 14, and 16-year cicadas. So for part B, let's say there's 12, 14, and 16-year cicadas that all appear this year. So this is our starting point this year. When will they appear together again? C, Stefan developed a method to determine the next time the two types of cicadas will appear together. He says that if you multiply the cycles together, this would be a cycle, this would be a cycle, you get the next time both types would appear together. Does Stefan's method work for any pair of cycles? If so, explain why. If not, provide an example for which Stefan's method does not work. So for pairs, is it possible just to multiply the two numbers together to tell how many years it'll be before they both hatch again at the same time? That's a good question. That's a good question. And the last one, D. For questions A and B, decide whether the answer is less than, greater than, or equal to the product of the cicadas. Decide whether the answer is less than, greater than, or equal to the product of the cicada cycles. And product, you know, is the answer to a multiplication problem. So that's problem 2.2, similar to the Ferris wheel, but in a way quite a bit different. And these are our friends, the cicadas. And you can read about that. Along. So how are we going to practice this? You are going to practice using a site called Brain Genie that I like to use. And in Brain Genie, it's a site where we can practice different types of math with a little bit more drill and repetition here. And I see that my site is down. Pause this video. So in Brain Genie, I've made you a goal, and the goal is called 6.NSB4. That's a standard, and for that standard, I've picked out 9 skills that will help you work with the original math vocabulary from this investigation. So what we'll do here is I'll have you log into your Brain Genie account, and we can do these skills one skill at a time. But let me show you how the skills will look. So the skills that you'll be working on start off with identifying factors. We start small and then we get a little bit more in depth. So when you click on your skill, you'll see this come up, and you'll have practice. If you're not sure what to do, you can watch a video. So the first one says select all the numbers that are factors of 11. What are the factors of 11? Well, 11 is a prime number, right? So 11 and 1. Well, 11's not there, so the correct answer must be 1. So you would choose 1, and it's not letting me select it. But that's sort of how it works. All right, I'll go over this more in class. Thank you for listening to this video. Make sure you have taken the notes into your spiral, and I think you're ready in class with your groups to work and solve problems 2.1 and 2.2.